I'm really excited to be able to now present you and introduce you to the new smart rules. So I guess smart rules is nothing very new to you. Smart rules have existed for quite a while. And they bring, for example, the benefit of being easily accessible, for example, in the cockpit, where we have a bunch of predefined smart rules, but they also do have certain limitations because basically you have your library of smart rules in cockpit, but it's restricted to the 11 one that are pre-configured. So you don't have really a chance to do change some parameters of those or add new ones. We do have in the analytics, in streaming analytics, also the chance to create additional rules, but those will then only be accessible to the ones with the access to streaming analytics. And it also requires some technical knowledge, and it is not yet possible to really make this easily accessible, though these pre-configured additional rules to other users that, for example, only have access to device management or only access to cockpit and that don't have this technical knowledge that is required to basically set them up. So there's a bit of a gap between those that do have the access and the technical knowledge and the ones that also still want to leverage them in various places. That's why we decided to go the next step, have a new evolution of the smart rules, and basically leverage the benefits of both worlds, the flexibility that you have with the analytics builder, allowing you to basically build whatever rule you want to accommodate the logic that you need for your specific use case, and to at the same time make it easily accessible. So we will also provide the same user experience that we had for smart rules, that everyone basically in the platform can use it. But we even go one step further, though. You can basically deploy them everywhere, not only on a device level, but also on group level, on any asset level or asset hierarchy level that you want. So you have full flexibility on that end. But we also make those rules available not only in cockpit, but for example, also in device management, and also in the specific context where they matter. For example, we will introduce, and maybe let's directly go to the next tab there, you can directly see it. We also make the smart rules now available we have a dedicated tab in the device management application for each device. So you can deploy then specific additional smart rules to your device in device management, and you can even further configure them. So we also have some additional samples we provide out of the box for specifically the device management use case, which include, for example, if your measurement that's sent by the device exceeds a certain limit or a certain range that you've defined prior, we also have this geofence functionality where we can define a rule and with this rule a geofence for this device, and maybe be it an excavator. And once the excavator leaves the construction site, you will automatically be able to trigger an alarm. And the benefit here is also that you basically can configure this smart rule additionally then in this specific device context, where you can not only activate a specific smart rule, but then also set certain parameters and thereby also contextualize the rule. But these are just examples. As said, you have with the streaming analytics access also full flexibility of creating your own smart rules. We also discussed various use cases in the context of device management. For example, health monitoring, monitoring the handling of operations on your device side, or the custom availability monitoring. So there are various use cases, and you really can create something that is relevant for your specific scope and use case. So the new smart rule functionality is already available as of today as public preview. You can just activate it like any other public preview in the preview tab. And you will also be able to leverage the already existing smart rules that you already know, the 11 ones that I mentioned that are already existing in the library, were existing in the past, that are also created with the new smart rules, and you don't have to start from scratch. So start whenever you want to give it a try and let us know what your experience is and share your feedback. Would be well appreciated. With that, I would like to hand over to Chris, speaking a bit about Data Hub.
Hi. So we haven't talked about Data Hub in quite a while on any of these, and not because we've not been busy, we have, but you will hear a lot more about Data Hub over the coming quarters. But this was something we really wanted to kind of talk about, because this is actually, in my humble opinion, really cool. So for those of you who use Data Hub, you'll know underneath Data Hub, we OEM, and quite proudly OEM, Dremio as our query engine. So earlier, well, a few months ago, Dremio brought out an MCP. And what that allows us to do is query the data you have offloaded with Data Hub using your favorite LLM. So proper natural language against it. So what we've done with this is we've taken it and we've forked it. It's open source from Dremio, and made the changes necessary so you can run it inside Cumulocity. So the MCP will run as a microservice. And using the public preview of the AI manager that Rahul showed you earlier in this session, and an AI chat which I think Nico built, we've embedded this inside Cockpit. So I'm going to show you a few videos and what this looks like and what sort of things I can do with it. It's bring your own LLM, as the agent manager is, but as you can see in this screenshot, I have the Dremio agent. We're still tweaking it and renaming it a little bit. So we have this AI chat widget, and I can now start to ask this question. So I started out with a very simple question, and hopefully the videos will all work, of just what tables can you see? Now, I have videoed this and I have shortened the length of time because there's a lot of factors on what the response time is like. So I'm going to be very open that, you know, the performance will vary based on a lot of factors. But I started out with just that very simple question. What tables can you see? And what I've done on the next slide is drawn out the text of what it fed back to me and highlighted a few of the things that I found quite interesting straight away. It's determined its Cumulocity IoT data. It's picked out the main tables I have offloading jobs for in Data Hub. So I have alarms, events, my device inventory. I have some GPS tracking. All my data is simulated. You'll see that. And actually, the LLM calls me out on that. I've got location data and temperature measurements. It's telling me some views that might be interesting around the latest data, and that there's a bunch of views that are created for easy query. So straight away, you get a good overview of what you've got in your data lake. So the next question I asked it was, how many devices do I have and what are they? I just wanted to see kind of what it could figure out about the devices that I had connected to my Cumulocity tenant. So again, I've shortened the videos and reduced some of the time on it. And again, we'll deep dive into the results. So it told me I've got 5 devices. So I've got 3 devices which are temperature sensors, 2 are doing location, and it's called me out that they appear to be device simulators of IoT data. And when I ran this demo, the temperature sensors seem to be the most recently active. I recorded these videos about a month ago. So the next question I asked it was, well, what are the temperature profiles of my devices? Now, anybody who spends a lot of time writing SQL, I couldn't write some of the SQL as quick as this can. So the SQL is generating, and you can actually grab it out of Dremio. Is something that, you know, particularly on the next example I'll show you, I think would have had me scratching my head. So again, let's dive into what it's pulled out. So again, I have 3 active temperature sensor. It's given me a nice table showing me what the averages are, the min max, the date ranges. I've run them in the standard deviation, but it's also brought out some observations. They're consistent. Of course they are, they're temperature sensors and they're simulated. The range is very similar across all of them. I have excellent data quality because I've got 7.6 million measurements. It's over 15 months worth of data in here, and there's no significant temperature drifts or anomalies detected. And that's simulated data. But now imagine running this on your real device data, because over the past year or 2 years, and seeing what observations this is going to come out with. So by this point, I was getting quite bold with this. I've got location data, and as we know, location data, it's one row per measurement, per kind of reporting in. So to work out the location and the distance, we're starting to get into some quite complex SQL, because I need to look at how far it's moved between each row, calculate that. It's also latitude and longitude. So I threw that in. In real life, this takes, my data set, it took a good few minutes to come out with, and as I say, I've shortened it. And what I got back from that is one of the devices moved further than the other, but actually there was very little difference in it. Depending on which LLM I use underneath, one of them turned around and said, your devices appear to be in the Dusseldorf area. The different LLMs are adding different value to it. In this particular case, I think I'm using Sonnet, Anthropic's Sonnet model. As you see, the second place device traveled almost the same distance. Now, I thought about how long it would take me to have written the SQL to get that result out of Data Hub and out of Dremio. I suspect it would have taken me a lot of Googling, and the best part of a day. I'm rusty, to be fair, since I wrote SQL in anger. But what we wanted to do by bringing this to your attention is, for those of you who use Data Hub, we're going to package this up. We're still in the process of that. We'll get that packaging out to people. We'll get some instructions on how to set it up in the AI agent and how to use it. We want you to kind of spark the imagination. But what the other side of this is we're seeing a shift in analytics away from dashboards. I think dashboards will still have their place. People still like predefined views of data. And Data Hub has all that integration into Power BI and Tableau and Qlik. But the ability to just ask those free-form questions and continue that thought of analysis in natural language, I think is going to be a game changer. Actually, in general, for the analytics market, I'm at Cumulocity, so I'm only interested in IoT data. But I think what we can do with this, and what we can sort of the way you can now work with that data that you've been diligently offloading, I think the insights people are going to get out of this are fantastic. So we wanted to get this out into people's hands. Now, if you can't wait the few weeks while it takes us to finish packing this up, you can actually use the Dremio NCP. So here's a screenshot where I use the Dremio NCP with Claude Desktop. Dremio have a free training module on exactly how to do this. So if you really wanted to get your hands on this today, it took me about half an hour to get it up and running. I didn't have Python installed or the right version, so there's a few dependencies on there. But you can get this running locally on your laptop or your desktop right now today using Claude. I've tried Perplexity. But we will package this up. We will get it out there. Going forward, we're talking to Dremio about what their plans are around this, about bringing it into their product formally rather than an open source component. So those conversations are ongoing. I talked with our product manager for this the other week, and he was blown away by what we'd done with it already, of just making it available inside our UI. So we expect a lot more about this in certainly the AIoT and Data Hub part.